Okay, this is our project of OOC. So our topic is major Cineplex website. So at the below is one member. Okay, for our topic outline, right, we have 9 topics. Here's an introduction, objectives, problem exists in the current system, a proposed diagram for existing problems, the impact of the diagram, lecture summation, comparison between existing method and proposed method, and pros and cons of proposed method, and the conclusion for the last. Okay, first the introduction, right? We are focusing on finding what are the flaws from the current system. Many of the businesses fail to operate outright due to bad design on the design that couldn't serve for users' needs. A badly designed system could drive the customers away. Our selected system is major Cineplex website. Our focus is how well the system has been designed by the engineers. We are also looking into the technology they are using to build the system. And furthermore, we are also looking forward to their UI UX design and unified modeling language or UML on the current major complex website. Objectives. Our objectives in this paper is to analyze the major Cineplex website by running through some of the UML framework with different diagrams to prove that the current system is actually not user friendly, and also it is very difficult for users to perform any kind of purchase via the website. Okay, for the following 4 of our objective is analysis of the current system as the first one. The next, point out the flaws. The third, propose that method to mix the flaws. Next is comparing old and new method and reason why the proposed method is better. And the last one is a limitation of proposed method. For the problem exists in the current system, there are several problems for in the current major Cineplex website. The first one is some of the problems are related to the process of buying a ticket of any movie from the website. The next is one other problem in the website is that the placement of the advertisement that is inappropriate to be placed in the Cineplex website. And furthermore, the existing problem is that the one kind of mixture of technology framework. For example, like in the current website, the system is using the jQuery and Bootstrap at the same time. And what about the another problem is the wrong procedure for purchasing. First of all, wrong purchasing protocol from the current system. From the major Cineplex website, right, the purchasing sequences is not following to any standard flow of purchasing. In fact, it's making a lot of confusion to the users who are trying to purchasing any ticket from the website. The current procedure of buying ticket from major Cineplex website are as follow like this. The first is select the movie and select the branch and timing, and which will then show the timing list again for user to choose. And select the timing again, select the seat number, and checking that seat number and seat types and the payment and the tickets for the last. Okay, next. From the current major Cineplex website, there are several advertisements being placed in the website. First of all, that they have their advertising system that is advertising something on their own business and other businesses partners, which has already taken a lot of space from the website. And the next is a wrong mixture of technology and framework. From the above 2 pictures, we can see that there are a lot of mixed technology framework being used to build the current website. More framework, meaning more links, also accessing speed, and also other unexpected performance failure as well. So this is a use case diagram. Okay, you can see the customer, right? The customer just purchased like 1 ticket and collect the tickets. But for the cinema manager, we add film, delete film, add skin, add showing, and cancel the showing. Okay. So this is a deployment diagram of the measures. Okay, for the next. The sequence diagram from the above mentioned steps in 3.1, right? One procedure for purchase. We can see that there are some steps being repeated and which making confusion to the users for buying tickets for any movie on their own choice. We think to solve the problem, we only need the below sequence diagram to make the solution better. We propose in the following sequence that from this select movie, select time and branch, select seat, confirmation and payment, and tickets. For the next, this is a sequence diagram of major snippet, right? You can see the consumer will log into the system and it will respond. I will, but before respond, it need a user credential and and it respond to it. The user sign it and it respond with the movie times and branch to the consumer, and the consumer can also select the movie branch time and seat number into the website, and the website will send to the database as a user selection, and the database will respond as a selection validation and respond back to the consumer as payment detail. The consumer will send the payment information to the major specific website, and it said and will keep the to the database as a payment consumer purchasing history. Okay, for next, the impact of the proposed diagram, right? The result from the above proposed diagram will make the whole information flow better from users to measure, and then to its own database. It provides a very smooth, harassment-free movie purchasing experience from the major Cineplex website. With the above proposed sequence of buying movie ticket, we can make sure that all users who come to the website for purchasing will have to make minimal effort of trying to buy, and it should spend less than a minute the whole process from step movie time, seat and branch. Okay, for the impact, right? This is a simple flowchart of proposed method. So the first one is authentication. Send it to the select movie branch. We'll select the seat number and types and payment confirmation and receive the ticket. Okay, for this one is the topic of a lecture summarization. Okay, what is OOP for everyone? OOP comes down to three things: polymorphism, inheritance, and encapsulation. In OOP, everything is an object. So for polymorphism, whether good or bad, neither really be tied or inheritance hierarchies, and so probably shouldn't be considered exclusive to OOP. Inheritance was a bad dream that most people have woken up from, um, which means they inherit things from parent like child parent classes that live as encapsulation, which is about keeping information organized and hide from other objects. And the encapsulation intro, right, to OOP was popularized in the late 80 and early 90 under the banner of this usable code. The original impetus behind it in the 70s was the desire to divide the core state by sorting state into separate boxes called objects. In this original vision, an OOP is composed of a graph of objects, each an island of state into itself. Other objects do not read or write the state of other objects directly, but instead send messages, while messages may trigger updates of state in the receiving object, and the receiving object may return information about its state. And state itself, strictly speaking, does not leak out of one object to another. In short, the object do not share or pass along references to state, but instead only report to each other with copies of stateful data. In this way, each object retains exclusive control of its own state, much like computers on a network may share copies of their memory content but remain in total control of their own memory. And in the simple word way of encapsulation, we try to hide information from other classes. Remember that we say, say everything is object. Now think of two objects access to necessary information from each other. Let's say object from class student and object from class teacher. They should not have access to each other's password information. We can achieve this by simply creating two different classes and make authentication feel private for each of them. And this inheritance is simple words, right? Which simply means we inherit things from a base class, same as we inherit a lot of our appearance like tallness or nose shape and so on from our parents. A famous example is person as parent class and teacher and students as child classes. Because no matter what you are student or teacher, we are all human, so we can be categorized as person. The next is a class diagram, right? Class diagram. Now we know about the class, object, inheritance, and encapsulation. So we need a way to show them before code anything, and that's where class diagrams come handy. A class diagram will answer to this question: what functionality and information will these classes have? How do they interact with one another? We can see these classes and so on. So this is a cross diagram example. So you can see this is an example of a bank and the customer. Okay. So in previous slide, right, we have an example of banking system class diagram. Let's break it down. We have 8 different classes. From bank to saving, each class have different fields as a variable and methods as a functions. You can see they have positive side or plus side beside them. You can understand meaning by looking at the picture in front of you. Each class have a kind of relationship with other class, quality and type of relationship does matter, which we will example study. Like you can see in the picture on the right side, the public is the, the side as a positive, the private the side as a negative, and the protected as a sharp, and the package as just like this side. Okay, for the next class diagram relation, right? So remember in our bank example, we have different connection. Here are meaning of each relationship, which we will explain each one by detail. The first is association, inheritance, derivation or implementation, dependency, aggregation, composition. For this, we will explain it clearly. The first is association. It is a relationship between two separate classes. It joins two entirely separate entities. Inheritance indicates that child or subclass is considered to be a specialized form of the parent or superclass. Aggregation is a special form of association which is a unidirectional as well as one-way relationship between classes. And last, the composition, a restricted form of aggregation in which two entities, or you can say classes, are highly dependent on each other. By having this knowledge, now we can simply understand that our banking system different classes and their different relationship with each other, and we can start implementing this class by coding. That's why class diagrams are very useful to understand how we really can implement a class. Okay, for next is a UML. As the name says, it's a modeling language helps software engineering model the software and create various kind of diagrams, such as class diagram we talked about earlier. UML allows us to create 3 main kind of diagrams. The first is structure diagrams, behavioral diagrams, and interaction diagrams. The first one is structure, right, which we show information about how data is organized. And the behavioral diagram is a simply functional requirement of software. And interaction diagrams is simply how each function works and how data is controlled. Okay. So next is UML tooling. We can create diagram by tools like Visio or online tools such as Draw.io. It's a very famous website which allows us to create any kind of diagram. Okay. And the comparison. Now we know about tooling and diagrams. Let's back to our project which we want to compare between Major Complex Thailand and Cathay Cineplex in Singapore website. In Cathay Cineplex, right, the protocol of buying any movie is as follows, like a select movie, quick buy now, select branch time and branch, payment information and ticket. And this is a comparison tables. So you can see, right, the major Cineplex will take a lot of time, at least 5 minutes, and the number of steps that you have to perform is 10 steps. But what about the Cathay website from Singapore? You just take a half of the specify everything like a time and the number of steps to perform. So comparison conclude from the above, right? Comparison, we can see we have to spend more than twice amount of time in major Cineplex as comparing to KT Cineplex to buy one ticket. Furthermore, the total number of steps that one has to perform is 10 steps in major Cineplex, whereas in KT it's only 5 from select movie all the way to payment receiving ticket for any user that comes to buy ticket. And the pros and cons on both solution, right? So for the advantages, right, is the fast selection, less harassment, fast purchasing, easy to pay, easy receiving system. And for the con, right, or disadvantages, the business might have to spend more budget, maintain more on the accessibility of the system, more budget on the secure of the website, more human is required to perform job. Okay, for the conclusion, right? For OC class, we learned that what does OC and OOP means, what are classes and objects, and then we learned about UML, which was based on layers of our classes. We learned that how we can use UML to create various diagrams for designing a software based on object-oriented methodologies. We learned that differences between diagram and that images, also syntax for relating these diagrams together. Based on all of these, we try and use the sequence among with other diagrams to show our proposed solution for our created existing problem system website. Okay, thank you everyone for watching our video. Okay, goodbye.